For months, 3I Atlas was just a distant anomaly, a blurred signal, a fast-moving object at the edge of our instruments, something far enough to debate, far enough to argue over, far enough to dismiss. But now it's no longer far. It has entered what astronomers call the final approach phase, the window where long-range estimates collapse into measured reality. And the reality is, it's not matching the forecasts. Because with every new observation, every refinement of orbital data, every recalibration of imaging parameters, one number keeps creeping upward. Not its speed, not its brightness, its size. For a long time, scientists estimated 3I Atlas to be comparable to a large comet nucleus. A few hundred meters across at most, something exciting, but not extraordinary. That estimate has now been quietly revised. Then revised again and again. Now, the current working models suggest something significantly larger. And not just slightly larger, potentially order of magnitude larger. And that has completely shifted the tone behind closed doors. Because size changes everything. Size affects gravitational behavior. Size affects structural stability. Size affects survivability. And most importantly, size affects intent. Not intelligent intent, but physical implications. And right now, the implications are unsettling. When astronomers started getting higher resolution measurements using refined parallax and motion modeling, one troubling pattern emerged. The brightness of 3I Atlas wasn't increasing in the way expected for an object of its estimated dimensions. It was increasing too slowly relative to distance shrinkage, meaning one of two things: either its surface reflectivity is abnormally low, or its actual physical surface is much larger than assumed. And since reflectivity analysis already showed unusual material behavior, the second option gained traction: a larger object with a darker, more complex surface. Not impossible, not unheard of, but extremely rare. Especially for something moving this fast through interstellar space. Then came the thermal reading. As 3I Atlas approaches the inner solar system, its temperature response under solar radiation should follow predictable curves depending on size, density, and composition. It didn't. Instead, its heat absorption pattern suggested a mass far greater than initial estimates. Not just surface area, internal mass. Meaning if this thing were hollow, it would warm faster, but it didn't. It retained cold interiors longer than models predicted, which indicates volume, material, mass, a lot of it. And that's where concerns started creeping in. Not because of danger, not because of collision risk, but because of what kind of object survives interstellar travel intact at that scale. Most interstellar objects end up like sand-blasted rubble. They get shredded, fragmented, eroded. Radiation pressure, micrometeorite impacts, thermal expansion cycles near alien stars. Very few large bodies survive that journey whole. 3I Atlas did. And if its true size is what current models now lean toward, then it shouldn't have. Unless its internal structure is far stronger than any normal comet or asteroid. And that's where things take a turn, because suddenly, size plus structural integrity becomes alarming. Not because it threatens us, but because it suggests a design philosophy not usually found in random cosmic debris. Again, not saying someone built it, but natural processes rarely produce massive objects that survive multi-light-year travel without significant fragmentation. That level of durability requires something else, either extremely rare material configurations or engineering. And here's where the conversation shifts from abstract to visceral. Because the bigger this object gets in our calculations, the more it stops feeling like a piece of space debris, and more like a remnant of something that once had a function. Not necessarily here, not necessarily for us, but somewhere, at some time. Maybe long gone, and that makes size matter, because a tiny artifact could be dismissed. A a massive one, that changes perspective. It's no longer a curiosity. It becomes evidence of scale, evidence of capacity, evidence that whatever made it, if that even makes sense, operated on industrial levels, scales beyond human civilization. Even if they're extinct now, even if it's just a dead fragment, the size tells a story. And right now, that story keeps getting bigger. Another factor fueling concern is its gravitational influence on surrounding dust particles. As 3I Atlas passes through regions of space with particulate matter, astronomers track micro-deflections to estimate its mass via gravitational interaction. The deviations were small, but larger than expected, meaning it's exerting more gravitational pull than its supposed size should allow, again pointing toward greater mass, greater size, greater density, and now, greater scientific unease. Because if its size is comparable to some of the larger near-Earth asteroids, then its classification changes. It's not just an interstellar oddity, it's a deep space macro object, a major traveler. And you don't normally get those crossing solar systems quietly. Most large interstellar bodies get captured or deflected or destroyed. 3I Atlas wasn't. It came in, clean, fast, on a trajectory that just happens to intersect the plane of our system. And that's what scientists can't fully explain. Because calculating its path backward suggests it wasn't randomly scattered. It wasn't just a loose rock kicked out of a dying star system. Its trajectory shows coherence, long-range coherence, as if it maintained direction over vast distances. Not common in natural ejecta. Most of those spiral, drift, randomize. This one didn't. And when you combine its size, its survivability, its directional stability, its structural coherence, it starts forming a pattern that doesn't sit comfortably inside existing cosmic models. Scientists still aren't panicking, and they're certainly not telling the public anything dramatic. But internally, discussions are shifting from, what is it made of? To, how did it stay like this for this long? And that's a much bigger question. Because if 3I Atlas really is much larger than originally thought, then odds are we've underestimated the scale of interstellar objects entirely. Maybe they're not all small. Maybe we just detect the small ones more often, and the big ones? They pass in silence, unseen, until technology catches up, until one gets close enough, until we finally notice one, like this. And here's another unsettling thought. Large size means it's old. Because the older something is, the more time it has had to grow, accumulate, or survive. And whatever 3I Atlas is, it's not new. It didn't just get launched. It's been traveling for a long time, potentially millions of years, potentially billions, which means its origin belongs to a timeline far outside human history. Before Earth had cities, before life had intelligence, before our species existed, and yet here it is, passing us now, of all times, which scientists dismiss as coincidence. But coincidence feels smaller when the numbers get larger, and everything about this object keeps getting larger. The closer it gets, the more detail emerges, surface shadow zones that imply height or depth, light refraction patterns suggesting internal layering, mass distribution anomalies indicating structured density. These aren't things you normally associate with loose space rocks. They're things you associate with formed objects, formed by processes that require time, pressure, or design. The next few months are where things will truly change. As 3I Atlas advances deeper into the observational range of Earth-based arrays and space observatories, the margin of error will shrink. We'll no longer be guessing at its size. We'll measure it. And if the current upward trend holds, then we may soon discover that we've been underestimating this object by a factor that makes our early assumptions look naive. Not because scientists failed, but because they didn't expect this scale. Nobody did, because nothing like this has entered our system in the age of modern astronomy before. And that's what makes this moment different. Not just another passing rock, not just another interstellar visitor, but something big enough, strange enough, persistent enough to force a re-evaluation of how we understand what drifts between the stars. Right now, 3I Atlas is still silent, still dark, still moving, but the data keeps speaking louder every week. And what it's saying is simple. This object is not what we thought. Not in behavior, not in composition, and now, not in size. And that might be the most alarming part of all. Not that it's dangerous, but that we may have no idea how much we just underestimated what's out there.